Today, we're securing a Next.js application using JSON Web Token or JWT. Unlike the traditional session that clog up server memory, a JWT is completely stateless. When a user logs in, the server generates a token, send it to the client, and forget about it. Every JWT consists of three parts separated by dots. The header specifies the token type and hashing algorithm. The payload holds user data like user ID or roles. The signature, a cryptographic proof created using a secret server key. Because of this signature, the token is completely tamper-proof. If a client alters even one character of the payload, the signature becomes invalid. When the user requests an update root in Next.js, the server just verifies that signatures. If it matches, they authenticate it. So that the lookup required. Let's jump into the code and implement this efficiently. Start with the login root. When the user submits their credentials, we validate them against our database. If they match, we use a library like JWT to sign a new token. In this, we're going to elevate our NextAuth configuration by implementing a custom JWT management system using the JWT library. Instead of relying on the default behavior, we take full control of our token and encode and decode within the auth option. First thing first, we need a lightweight and secure library for handling JSON Web Token. We use JWT. Let's install it via npm. Once installed, navigate to your auth configuration file, auth.ts, and import the necessary utility from the package. Import sign JWT, JWT verified from JWT. Next, we need to ensure our environment is secure. We will map our NextAuth script from the environment variable directly into the auth option object. Right below that, we introduce a custom JWT property, which will house our custom encode and decode method. Let's write the encode function. This method intercepts the token creation process, allowing us to sign it manually. It accepts an object containing our script and the current token payload. Inside, we wrap our logic in a try catch block for robust error handling. First, we convert our script string into a cryptographic friendly byte array using text encoder. Next, we normalize our SUR and expiration timestamp, defaulting to a 30-day window if they aren't already present. Finally, we extract the token payload. Instantiate new sign JWT. Set the protected header to the AS256 hashing algorithm. Establish the expiration. Sign it with our crypto key and return the newly minted token. Now that we can encode, we need to reverse the process. The decode function takes the incoming raw token string and the script to verify its authenticity. We first add a guard clause. If no token is provided, we immediately return null. Inside our try block, we again generate our crypto key. Then we pass the token and key into JWT verify, explicitly declaring AS256 as the allow algorithm. If the token is valid, we extract and return a decoded payload. To tie everything together and make sure our session duration matches our token lifespan, we need to explicitly configure the session property that under MaxAge option, setting it to 30 days, measure in seconds. With our main configuration set up, we need to ensure our middleware align with these changes. In your middleware file, we inject the same NextAuth script into the configuration. To seamlessly handle session violation RDH, we will port over our custom decode logic directly from auth.ts into the middleware JWT option. Now that our configuration and middleware are synchronized, it's time to verify the implementation. Fire up your development server. Let's spin up the application. Navigate to localhost 3000 in your browser and test the authentication flow using the test account. As you can see, the authentication succeeds and we are routed directly to the dashboard. To verify that our custom encode and decode routine are actually processing this token, let's execute a temporary diagnostic log. Head back to the decode function in your configuration and add a console log statement to output the incoming raw token and it is a payload. With the logger in place, let's initiate the login sequence one more time. If we check our terminal, you see the custom signed JWT string printed out, followed by its successful verified payload. This confirms that NextAuth is fully utilizing our custom cryptographic lifecycle. And there you have it. From break breaking down the three-part structure of a stateless JSON Web Token to overriding NextAuth default behavior with our own custom JWT, encoding and decoding logic, you now have complete control over your application cryptographic lifecycle. Your Next.js app is officially secure, highly scalable, and optimized for performance at the edge. If the hands-on breakdown help you understand JWT and NextAuth a little better, please smash that like and subscribe button. It really helps the channel out and push the content to other developers looking to level up their security. I would love to hear from you. Are you planning to stick with traditional cookie JSON, or are you moving completely stateless with JWT for your next production build? Let me know in the comment section below. If you run into any session with the JWT configuration, drop your question here too, and I will do my best to help you debug. Thanks for tuning into ScienTeck. Keep coding, keep securing your app, and I see you in the next video.